So vector is a quantity which has both magnitude and direction. You know that already. It's just there as a review. Examples of vectors include displacement, velocity, acceleration, force. I've called those the big four. To fully describe one of these vector quantities, it's necessary to tell both the magnitude and the direction. For instance, if the velocity of an object was said to be 25 meters per second, then the description of the object's velocity is incomplete. You have to include the direction as well, right? In order for such descriptions of vector quantities to be useful, it's important that everyone agree upon how the direction of an object is described. And oddly enough, the science world has not been able to come up with a universal method of vector direction, and so people are forced to be bilingual kind of thing, trilingual almost. Most of us are accustomed to the idea that up on a map refers to the northward direction and right on a map refers to the eastward direction. This is a mere convention which map makers have used for years and upon which we can all agree. And you may have seen online, there's maps made of the globe, the earth, flat maps where everything is flipped and Antarctica is at the top. Okay, it's just convention. We don't do it that way. What if the direction of a vector quantity is not due north or due east, but somewhere in between? For such cases, it's important that there be some convention for describing the direction of such a vector. We will use the bearing method that has north at 0, right there, and then rotate clockwise, right? So 45, 90, 135, 180, and so on around the horn kind of thing. If it says NE, what does that mean? Northeast, but what's the angle length? 45, exactly. And people will also talk about, oh no, don't do that. People will also talk about, they'll say north. I closed it, didn't I? Jeez. Yeah, I guess that's it. Call it a week.
That's fine.
As I was saying before I was rudely interrupted, people might say north, northeast. Okay, and so what that refers to is halfway in between those two. I'm not going to do that, but just in case you ever run across that, that's kind of what it means. Okay, now regrettably, mathematicians like to start over here at east at 0 and work their way this way. Only people in math classrooms do that. It has to do with the unit circle. Have you visited the unit circle yet? It's a happy place, isn't it, the unit circle? No, not so much, I know. Okay, if you want more info on that and airplane navigation, there's a link I provided for you. I did check. Let me just see here if I can get in. Why did I have that all paused during that time? That's no good. Oh, well. No, it's important. Does the order matter, Graham? No. And you know what? Oddly enough, after I've said the order doesn't matter at least 20 times, showed it to you yesterday, showed it to you today, there will still be kids, maybe one today, certainly some on Monday, that will say, does it matter which order I put these in? I'll look at them and go, does the order matter?
No.
Yes. No, the order doesn't matter. Okay, now, who cares about this in real life? Is it just physics teachers and math dudes? No. Pilots care a whole lot, and especially the people that are flying in the plane, they care. They just don't have to do it. They just sit back and enjoy their little bag of peanuts and away they go, right? But the pilot, the navigator, yeah, I don't need to do peanuts in the plane anymore. The navigator, he needs to know all this vector stuff. So, observe the 3 planes in the animation below. Each plane is heading south with a speed of 100 kilometers an hour. Each plane flies amidst a wind which blows at 20. In the first case, the plane encounters a tailwind, which means from behind. The combined effect of the tailwind and the plane provide a result velocity of 120. So I'm going to have to find that plane one. Here it is. There it is there. Okay, so there's the planes. Now you can see it's not a race, it's 3 different situations. Which one has the tailwind? This one has the tailwind, this one has a headwind, and this one's got, what do you mean by 9 wind? Crosswind, yeah, sideways, right? Sideways. Okay, I think I've got another one that describes that better here. Oh yeah, like that, right? Is that what you expected? Well, this one's not an animation. Something like that, right? Okay, so what I'd like you to do is I'd like to just draw this in right here. Okay, so we're going to go, and if you've got a different color, it would work. If not, you're just going to have to label. So there's the plane, and I put that little vector thingy over top. And here's the wind. Now, when they're all lined up like this, where's the resultant?
W.
Remember, where do you draw the resultant from? From where you started to
Yeah.
where you ended. So really, it's going to be like this blue thing here. It's going to be like that, right? Oh, just oh.
Good night. We close.
Just thinking about it. Okay, so the blue one there is what we call the result. Now, could I just, for sake of drawing it, oh, I can't do it now, but could I move it to the side? Like, is it okay if you move a vector around on the page? Yeah, what's the only thing that matters? How long it is and the direction, right? Okay, so now the next one. Yeah? Yeah? Are you asking me something about it? Well, you just put it over top. I don't. Yeah, it's not the best situation, right? Yeah. Okay, so this one here. There's the plane. Now, if the wind is a headwind, I start from right there and go back like so, right? And the overall resultant, which is blue, is from there to there. I kind of drew it a little bit to the side so you can see it. Is that making sense? Again, if there's a side wind, oh. Weren't you just here? But I'm going to show you the actual. I've given you the sort of the idea, the theory. Now I'm going to give you the actual mathematics. How do we actually do it, Mr. Bennett? Well, first of all, don't break your ruler. Second of all, make sure you got a ruler and a protractor. Okay? All right. And again, as always, feel free to not write everything down. Some things are so simple that you don't need them. Others here may not be so. But it doesn't mean just don't do anything, right? At the very least, you got to know how to add vectors by Pythagoras and add vectors by scale drawing at the end of today. So, if the vectors are on the same line, it's cause for celebration because they're easy. If two vectors are in the same direction, it's easy to add them. Place them head to tail, like I did here, right? And simply add them together. Simply measure the total length, or add the two magnitudes together. And it kind of looks like this. Right? There's the 8, there's the 6. Here comes the resultant, 14. Pretty straightforward, right? Want to see that again?
Yeah.
It's pretty exciting, I know. There's the 8, there's the 6. Start from the start, end at the end. There's the 14. What's the 14 called? Resultant.
If you would actually go on a piece of paper, would you just want to put that 14 like under the...
Yeah, you could. If you want to just, because is that the same?
Yeah.
It is the same. And that's perfectly fine just for a better visual kind of picture. I'll understand what you're doing. Right? I'll understand that you really mean, well, it's like that. I just can't see it very well. So I've moved it. That's perfectly all right. Okay. You shouldn't have any problem just adding vectors on the same line. That's pretty straightforward. Our ultimate goal today is by Pythagoras or by scale drawing, right? I ask again, does the order matter? Let me show you. 6 plus 8, 14. Does the order matter? No. Do not ask me if the order matters. I will mock you. But what if they're not in the same direction, Mr. Bennett? How do you add them? Here's how you do it. Always, always, always. And I really don't like the word always because it doesn't leave a lot of room for exception. You know, like if I said, Matt, you're always late. That would mean that every day he is late. Oh, hang on.
I did go on, he was here.
Oh, is that right? See what I mean? You can't say always. Get here on time, Greenie. Place the vectors tip to tail again and measure the result. How do you measure it? With your ruler, the one that's behind your ear or in your holster. Place the 8 and the 6 tip to tail, and if it's east and north, then like so. And then where's the resultant? Right there. How do you find out how long it is? Use your ruler. It's not 14. It's not 14. It's going to be less than 14. The only way it can be 14 is if the 6 is like this, right? That distance there is 14. Right? So it's going to be, well, is it going to be bigger than 8?
Yeah.
It has to be bigger than 8, right?
Right.
10? Something like that? Okay. Use a ruler, oh, I should say, and protractor. You're right, it is. How do you know? Yeah. Pythagoras, right? Or if you've taken carpentry or woodshop, you'll know the 3, 4, 5 rule, right? Isn't that just a 6 a multiple of the 3, 8's a multiple of 4, and there's the 5, right? Good old 3, 4, 5. Use a ruler and a protractor, or if they are perpendicular. Now, I can't stress this enough. Let me get on my highlighter, and I'm going to highlight perpendicular, and then I'm going to put like fancy thing around it like this, because in June I will sit in this very chair and I will say people's names, and I will be so frustrated because you will be adding vectors using Pythagoras that are not perpendicular. You cannot do this. You cannot use Pythagoras for that. Why not? Not perpendicular. Why am I yelling? I am mad. It's so frustrating. It's like, oh, were you not listening on that day? They must be perpendicular to do what? To do that a squared equals b squared plus c squared thing. If they're not perpendicular, you can't do it. How many people know the cosine law from math? Okay? The cosine law looks an awful lot like Pythagoras, right? You got to use the cosine law. They must be perpendicular. Okay, so here, now I got 5 and 8. This should really be, this is a screw up here, isn't it? That should be a 6. Let me redo this for you here. That should be 6 squared plus 8 squared, and I think Kieran was right? So it's going to be 36 plus 64. R squared equals 100. So R is the square root of 100, or just plain old 10. 10 what? These are said to be kilometers, so that's going to be 10 kilometers as well. Okay? You can all do Pythagoras, right? Grade 9, I think? Something like that, right?
So that second part's wrong too.
Yeah, actually it would be, right. Thanks. Okay, so let me do it for you, right? So we got opposite, adjacent. Is it always going to be tan?
No.
Yeah, it pretty much is. Because it's always going to be this vector and this vector, and you're always going to be finding the hypotenuse, right? Almost always. I shouldn't say always, almost always. So tan theta is going to be opposite over adjacent. I guess the first step was right. So tan theta here is going to be, it's going to be 6 over 8. Theta equals the inverse tan. Have you seen that convention before, tan minus 1? That's what they use in math? Okay, good. If you want, I'm good with just starting from here. I don't need these steps. I know this. I think you know that. I'm good with theta equals inverse tan of 6 over 8. So theta equals...
The one before was the over 5.
I had a wrong... I think I redid these, and I probably had 8 and 5, and then...
Your red line's wrong.
Is it? What's wrong about it?
It's supposed to go to
Ah. Is he right? No, Peter? Why not? You're right, Peter. He's wrong. Sorry, Matt. You're wrong, Matt. Or you know what? I'll pay you after for asking that question. Because I told you to ask that question, right? To make a point here. Yeah, I told, that's why I was late. Should it be tip to tail here?
No.
No, you have to start your resultant from where? Where you started to where you ended. This is the only one that's not tip to tail. This is the one that has to be tip to tail. Okay? So, now, what's the number one mistake people can make when doing these questions, besides that using Pythagoras when they're not perpendicular? Calculator is in
Degrees.
radians. That's the mistake. So make sure your calculator's in degrees. So, second function tan, 6 divided by 8. If you're having calculator issues, I'm pretty good at solving most of them. I get 37 degrees. 37 degrees. Can you do those, do you think? Really, all I'm doing is taking some of the stuff you've learned in about grade 8 and 9 and applying it to a slightly different situation, really, right? It's just Pythagoras, that's all it is. I'm going to go through the whole thing. Okay, as I wander around, it's clear to me that I need to do some more work here. Okay? Drawing the picture shows me that you understand. If you don't draw the picture and you get things wrong, it's very difficult for me to give you any credit. Okay? So let's draw this. A man walks 3 kilometers north. So, 3, right? Then 1.5 east. Tip to tail. I saw quite a few people with this. It's got to be this. Tip to tail. He walks 3 north and then 1.5. It must be tip to tail. It must be. Now, what if I drew this, Mr. Bennett? What if I went 1.5 and then 3? That's okay. It just doesn't match sort of the story here, right? Is it going to give you the same answer? Yep. But the better one is likely this one here, right? Where is the resultant? From where you started to where you ended. Label that with an R for resultant. Okay? Now that you've got your picture, you've got to decide, is this perpendicular? Yeah. Of course, it's north and east, right? It's perpendicular. I can proceed with Pythagoras. And so now you would write something like R squared is equal to 3 squared plus 1.5 squared. R squared is equal to 9 plus whatever that is. 2.25, I think, is it? Can you reduce some steps here? Like, you have to write every little thing down? No, I'm fine with that. We're big boys and girls. I get 3.4. You're only halfway there. How come? Graham, really? I get 2.4 kilometers, but am I done? No, I also need I need the angle. I had a question. How do you know which is the opposite, which is the adjacent? There's the angle. Now, the number one question that kids always ask me is, where do I put the angle? Do I put it there, or do I put it there? And I say to you, if I told you to go for a walk, you'd probably ask me, which way do you want me to go? So I have to give you the angle at the start of the resultant, not at the end. The resultant angle is from the start. Okay, so opposite to that is 1.5, right? So you would just write theta equals inverse tan, opposite over adjacent. What's the opposite? 1.5. What's the adjacent? 3. So you go on your calculator, 1.5 divided by 3, and then you go second function tan. Now some of you might have to do it the other way. .5 divided by 3. Well, I went the wrong button. I get 27 degrees. That's going to be north, 27 east. Okay?
How
It depends on what kind of calculator you have. There's the reverse Polish ones, and then there's the regular ones. Okay, so most calculators nowadays, you do it in order. You go second function tan, and then a bracket pops up, and then you go 1.5 divided by 3 bracket equals. If your bracket doesn't pop up, then you go 1.5 divided by 3 equals second function tan, or second function answer equals. Okay, every calculator is a little bit different, unfortunately. And I can help you. I'm pretty much good on all calculators.
Are you in for that?
So we're going to go 120 east. Then we're going to go 20 south. And then we're going to have the resultant from there to there, right? That's the picture I'm looking for. If I see that on your page on the test, boom, I know. They know what they're doing. It's pretty easy for me to tell, quick. Then you'd write what? R squared is equal to 120 squared plus 20 squared. And I usually just jump right to the answer. Is that okay?
Yeah.
Are you good with that?
Yeah.
120 squared plus 20 squared equals, and then take the square root. And I got 121.65, just like these guys did.
Was it 121.65 by 2506?
It was. If you want to use the full mantissa. There's the angle. From where you start. Yeah, so theta equals inverse tan, opposite over adjacent. 20 over 120. Right?
Nine.
Are you getting opposite? You doing that though?
Oh, I bet you.
I get 9.5 degrees. Yeah? 9 degrees. I'll round that down to just 9 degrees. So that's going to be east, 9 south, right?
What did I do wrong?
I don't know, man.
499.
Go 20 divided by 120, and then you got to go equals.
Oh, what the heck?
There you go.
I can use second. I don't want to get that.
Hey!
I got five.
It's 20 over 120.
Yeah, I know that. I don't know.
This end over here. Opposite is my one. No, opposite. Yeah. I always put the in there. Okay. Opposite. It's always the start of the result. Okay. Where there's no arrow right? So. Okay.
What's east 9 5?
East 9 south. Right? East 9 south. Okay, now, Mr. Bennett, what do we do if they're not perpendicular? What do? You use your ruler and your protractor.
Alright, sounds like a
If they're not perpendicular, you use your ruler and your protractor. Add the following. 10 at north, 30 east, plus 8 west, 15 north. Now I will caution you, when you do these ones, you have to plan ahead a little bit. You got to think about, where should I start this on my paper? Because quite often what happened yesterday, you ran off the paper. So you sort of got to plan it out, map it out ahead of time. Think about it. North 30, I like to draw a little sketch on the side. North 30 east means north 30 east. And from there, I'm going to go west 15 north. West and then 15 north. So my picture's going to look roughly like that. I'm going to start right up here in the top left-hand corner. Terrible idea, but I see it over and over and over again. Okay? If I'm going to have this, I'm going to have to start where? Way down here somewhere. Now, on the test, I always put these questions and I leave the entire page for you to do it. So you have no excuse. You just got to sort of think it through. So I'm going to start way down there, and I'm going to go north 30 east. Now, before I do anything, I need my scale. How do you start a scale? Always, always, always with the words 1 centimeter equals. Always. I had a couple guys who wanted to use millimeters. I'm okay with that. 1 centimeter equals. I've got 10 kilometers and I've got 8. What scale should I pick? 1 centimeter equals? Maybe 2? I would even take 1. Right? Make it something reasonable. If you make it too tiny, then you get a lot of error. 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 Yes, it is a weird word. Weird word. Yeah. Yeah. 10 north, 30 east. It is Friday. I'm giving you a lot to think about on a Friday. There's my reference line. North 30 east. North 30, and then I'm going east from there, right? So now I need a protractor. And so do you. Insert protractor. Excellent. Now, put your protractor there. 30 degrees to the east, right? There's 90, 10, 20, 30, right there. Get rid of the protractor. Now I need a ruler. Whoa. Come on, you. Yeah, and I'm going 10 kilometers or 10 centimeters, right? Okay, so I got to put this at 10. Come on, you. No, I didn't want that. Where's the rotate thing? There we go. Oh, it's rotating from this way. Okay. Yeah, you think it's all fun and games being a teacher, but you know. There we go. Okay, so now I'm going to draw my line. I get to draw it straight, so it's going to be 10, right? Now, quite often people find that it's a little easier to put the arrowheads on after because it kind of mushes up your spot there, right? Just don't forget to go back and do it. I have this luxury, I can do this. I'll just put an arrowhead at the end, but okay, but it's important to have that arrowhead on there. It shows me that you understand direction, so please put the arrowhead on it. Okay, now what do I do next? Do I put my next vector starting from down here?
No.
No. Where do I start it? Head to tail. You must start it from there, just like the treasure map that we did. That's why I do the treasure map first, to get you thinking about that. You must do that. I'm going 8 kilometers west, 15 north. Should I draw in a little reference line? Yes, I should. Little reference line right here that goes straight west. And from there I'm going to go west 15 north. Put your protractor on there. Oh. Get it nice and straight. 15 north is going to be right there. And now I'm going to go 8 kilometers or 8 centimeters. My 0 there. And I'm going 8 centimeters, right?
That's north or west?
That is north of west, yes. Or 15 west, west 15 north. And I'm going 8 long, right? Does my picture look sort of like my original sketch? A little bit. I didn't quite go far enough here, right? But I was just using this for what? Just sort of to figure out where to start on the page. I'll pause for a second. Where do I draw the result from? Where do I draw the result from? From where you started to where you end. This one here is the result. Do not connect the circle. Don't do that. Draw from the start to the end. How do I find that length? Do I go 10 squared plus 8 squared? Why not? Not perpendicular. Give that man a star. Or a round of applause. I will shake my finger at you if you do that. Don't do that. How do we find out how long it is? Use the ruler. It amazes me. People draw that and they measure it with a ruler. They draw that with a ruler and then they don't think, oh, I could measure that with a ruler. No, they go and do the square thing. Don't do that. Well, do it unless if you want to drive me crazy, I guess. Okay, so measure it. Does it matter where you measure from? Like which end? No, that doesn't matter. I get like about 11.2.
They call 11 even.
I get 11.2 centimeters. Can you be a little bit out? Yes, plus or minus 3 millimeters. I can do it mathematically and figure out the correct answer, and then I know how much range to give you. Here it's 11.2 centimeters, which is equal to 1 centimeter equals 1 kilometer, so 11.2 centimeters would be 11.2 kilometers. I know I'm throwing a lot of information at you today. Am I done, Jake? Why not? Well, it's either yes or no, and it's 50-50, right? What's the one thing I need still? I need the ruler. Very good, Graham. Or I need the angle. Now, where do you measure from?
Beginning.
You have to measure at the beginning, and you have to measure from the reference line. Don't measure from this. You have to measure from north. Okay, so you put your protractor in there, and you measure that angle, and it looks like it's going to be about 14 degrees, roughly. Hang on here, let me get that in the right spot. It looks like about 15 degrees, roughly, right? So that's going to be north 15 west. Now, are you going to get faster at these? Yeah. Yeah, you should. And I realize I've thrown a ton of information at you. Okay? Let's do one as practice and then we'll call it a day. Oh, they don't even have it. I'm going to give you a practice one. Yeah, come on, because if you practice it, you'll get it.
Tuesday. Oh yeah, working. In the middle of it, like this. I'm laughing. Okay, add those together and we'll check real quick. 5 kilometers per hour at north 10 east, 3 kilometers per hour at east 20 south. Go.